Good morning, my dear students. In today's class, I will discuss design of shaft with an application problem. So, this problem is available in worksheet 1. So I will be sharing with you in due course. A shaft 1500 millimeter long is supported at 2 points A and B. Point A is at the left extreme end of the shaft. Point B is at a distance of 400 millimeter from the right extreme end of the shaft. See, so this is the length of the shaft, 1500 millimeter. Point A is at the left extreme end of the shaft. Point B is at a distance of 400 millimeter from the right extreme end of the shaft. The shaft transmits a power of 50 kilowatt. Shaft transmits a power of 50 kilowatt at a speed of 500 rpm. At a speed of 500 rpm. Through a pulley of diameter, I think the pulley diameter is 400 millimeter. Through a pulley of diameter 400 millimeter that is mounted at the right extreme end of the shaft. So this is the pulley. So a power of 50 kilowatt at 500 rpm is transmitted through a pulley that is mounted at a distance of, at the right extreme end of the shaft. At the right extreme end of the shaft. This pulley is driven by a belt. So as viewed from the right hand bearing, direction of view, you see here, direction of view. This pulley is driven by a belt. So as viewed from the right hand bearing, this pulley of diameter 400 millimeter, I think 400 millimeter, diameter of the pulley is 400 millimeter, is driven by a belt inclined at 60 degree below the horizontal and away from the observer as viewed from the right hand bearing. You see, as viewed from the right hand bearing, this pulley is driven by a belt inclined at 60 degree below the horizontal and away from the observer. So you must know that. So suppose if it is towards the observer, it will go like this. Now it all depends on the problem. In some problem, the pulley will be driven by a belt inclined at say 60 degree or 45 degree, whatever it may be. It may be away from the horizontal or towards the horizontal. So as viewed from the direction of view is very important. So in this particular problem, the direction of view, it is viewed from the right hand bearing. As viewed from the right hand bearing, the pulley is driven by a belt inclined at 60 degree below the horizontal and away from the observer. So it is away from the observer. So it is like this. So this pulley, so this is the shaft to be designed. This pulley is driven by a belt inclined at 60 degree. Below the horizontal and away from the observer. So this is away from the observer. So you must know this, whether the pulley is driven in front of it or away from it, whether it is away from the observer or in front of the observer, whether it is below the horizontal or above the horizontal. It all depends on the problem. So in this particular problem, the pulley is driven by a belt inclined at 60 degree below the horizontal and away from the observer. Okay. So this is your T1 plus T2. So it all depends on the direction of the pulley. Whether it's a driving pulley or a driven pulley. Whether the pulley is rotating in clockwise direction or anti-clockwise direction. Now in this particular problem, if that information is not given, in that case let us assume that the shaft is rotating in clockwise direction. So because this is the driven pulley, the direction of the tension side, the tight side tension will always be in the same direction as that of the rotation of the driven pulley. So we have to show T1 here because T1 is the tight side tension. So the direction of the tight side tension will always act in the same direction as that of the rotation of the pulley. So T1, T2. So this is the T1 plus T2. So now, okay, now the power is received by the shaft through a pulley or by means of a pulley through a belt inclined at 60 degree below the horizontal, and it is away from the observer. Now whatever the power that has been received by the shaft will now be delivered by means of a gear. So where that gear is mounted, so that gear is mounted at a distance of 500 millimeter from the right hand bearing. So 500 millimeter. So somewhere here. So the diameter of the gear is 200 millimeter, P circle diameter. So that is 200 millimeter. Now let me show somewhere here. We are having this gear. This is the gear that is mounted at a distance of say 500 millimeter from the right hand bearing. It is understood it can't go on the left side of the right hand bearing because only we have got 400 millimeters already. That is the extreme left extreme, right extremity of the shaft. It is understood. So it has to be to the right of the, to the left of the right hand bearing. It can't be to the right of the right hand bearing. It always should be to the left of the right hand bearing because it can't go to the right of the right hand bearing because the maximum distance available to the right of the right hand bearing is only 400 millimeter. Already that is the right extremity of the shaft. Okay, so there is a gear that is mounted at a distance of 500 millimeter from the right hand bearing B. So of diameter, P circle diameter 200 millimeter. So P circle diameter. Now this gear will drive another gear. This gear will drive another gear. So that is located in front of it. So please note, this is the gear that is mounted on the shaft to be designed. This is the gear. So of course you cannot see this gear because it is hidden, because as viewed from the right hand bearing, we cannot see this gear. So that is hidden, it is not visible. So that's why I have shown in the dotted circle. Now this gear is going to drive another gear that is located in front of it as viewed from the right hand bearing. So that is the direction of view. Now already we know the direction of view. We are viewing from the right hand bearing. So as viewed from the right hand bearing, this gear is going to drive another gear that is located in front of it. So in front. So this is the gear that is located in front of it. Somewhere here we are having that gear. Okay, because I don't have space here, so let me adjust some more here. Okay, so a P circle, say 200 millimeter P circle diameter gear, say gear D. So let us call it as gear D. Gear D, this is pulley C. Pulley C. So driven pulley, this is the driven pulley because the power is received through a pulley. The power is received through a pulley. So that's why it is a driven pulley. Whereas here, the power is delivered to some other unit. Why means a gear. So it is a driving gear. So now the power is delivered. So this is a driving gear. So it is a driving gear. This is driving gear. Driving gear D. Now this gear is going to drive another gear that is located in front of it. Is it clear? No. Okay. So this is the space diagram. So we have shown the space diagram here. What is called a space diagram? Space diagram. Okay. Now after that, what is that I have to do? We have to analyze one by one. Now let us start analyzing pulley C. Analyze pulley C. So before analyzing pulley C, first of all let us find out torque. What is torque? P into 1000 into 60 divided by 2 pi n. We know the power, we know the speed. If I just substitute for power and speed, I think we will get here how much? Torque 955 Newton meter. So I will get 955 Newton meter, or it is 955 into 10 raised to 3 Newton millimeter. Now please note that in this particular problem, whatever the power received by the shaft will be delivered to only one unit. So in that case, whatever the torque that is available at pulley C is same as the torque that is available at gear D. In other words, T is equal to TC is equal to TD. So that is the assumption we have to make here in this particular problem. In some other application problem, it will not be like that. It may be different. For example, whatever the power received by the shaft will be delivered to 2 units. For example, a power of 50 kilowatt received by the shaft, say through pulley, now that power will be distributed to 2 units. Say out of that 30 kilowatt power will be distributed to 1 unit, now remaining 20 kilowatt power will be distributed to unit 2. No, like that. It depends on the problem. Whereas in this particular problem, whatever the whatever the power that is received by the shaft will be delivered to only 1 unit. In that case, whatever the torque that is available at pulley C is same as the torque available at gear D. So T is equal to TC is equal to TD. That is 955 into 10 raised to 3 Newton. Okay. Now let us start analyzing one by one. Analyze pulley C. Analyze pulley C. If I analyze pulley C, what is that? You will draw pulley. First you have to draw that pulley, whatever that pulley we have shown there. So the direction of, you see, what is that? It is inclined at 60 degree below the horizontal and away from the observer. And away from the observer. This is like away from the observer. So this is T1 plus T2, and we have to resolve this. This will be T1 plus T2. This is T1, this is T2. T1 plus T2 cos 60 here. So vertical component is T1 plus T2 sin 60. Now we have to resolve this. T1 plus T2 into horizontal component and vertical component. Horizontal component is T1 plus T2 cos 60. Vertical component is T1 plus T2 sin 60. Apart from that, I think the weight of the pulley is also there in this particular problem. Weight of the pulley C. I think weight of the pulley is given here 1000 Newton. So weight of the pulley C, WC is 1000 Newton. That also is there. Here you have to show that WC is 1000 Newton. 1000 Newton. This is WD. I think WD is also there, 400 Newton. So you can't neglect that because weight of the pulley and weight of the gear are given here. So you have to consider that weight of the pulley C. Now after that, after simplification, I think before that we have to find out what is T1 and T2 because we don't know what is T1 and T2. But we know the torque, relationship between torque and net tension driving the pulley, T1 minus T2 into R, correct? So T1 minus T2 is the net tension driving the pulley into radius of the pulley is nothing but torque, TC. Now if I find out, see if I solve for T1 minus T2, I will get, I have substitute the value because already I have found here, 4775 Newton I will get. 4775 Newton and T1 by T2 is equal to e to the power mu theta, that also will solve here. T1 by T2, if I solve for, because mu is given in this particular problem, mu is 0.3 and theta is 135 degree. Now I have given 135 degree. Now just substitute for mu and theta here. Now theta e to the power of 0.3 into 135. We have to convert it to radians. So please don't forget to convert it to radians. It can't be in degrees. You have to convert to radians. If you find out the ratio here, T1 by T2, I think you will get 3.18. 3.18. So T1 by T2 is 3.18. This is equation 2. Let us say call it as equation 2. So let us say T1 minus T2 4775 is equation 1. If we solve for T1 and T2, I will get T1 is equal to how much? 1 minute. 6965 Newton and T2 is equal to 2190 Newton. 2190 Newton.